30.4 Newton force is used to slide a 40 Newton crate a distance of 6 meters at a constant speed along an incline to a vertical height of 3 meters. 81. Determine the total work done by the 30.4 Newton force sliding as the crate slides along the incline. So we're looking for work. So for 81, we want to know work. What do we know? Well, we want the work done by this 30.4 Newton force. We also know that the object is slid a distance of 6 meters. Work, force, distance, their equation is going to be W equals FD. Plug in our values. And when you multiply the two of them together, you get 182.4 joules. The amount of work done by this force. 8283. Calculate the total increase in gravitational potential energy of the crate after it has slid the 6 meters along the incline. So gravitational potential energy, equation here is potential energy is equal to m times g times h. Something to notice here. The height. Well, height is a vertical value. How far directly upwards it went. And so the height would not be the 6 meters. The height that we're going to plug in is the 3 meters. Now what's interesting about this problem is the mg portion of the equation. mg. Well, mg should look familiar. mg is the equation for the force of gravity, or the weight of an object. Now in this equation, they actually gave you the force of gravity, or weight of the object, as 40 newtons. And so what you're allowed to do here is take that 40 newtons and plug it in as m times g. When you do that, you get an answer of 120 joules. So taking that shortcut saves you a step. What you can do is you can take the 40 newtons, solve for the mass, and then plug it back into the equation. You should wind up with 120 joules again, but it's an extra step of work that you really didn't have to do. Either way, as long as you showed all of your work, and you wind up with this answer, you're in good shape. 84. What happens to the kinetic energy of the crate as it slides along the incline? Now the object is going up this incline. We don't know what happens to the kinetic energy. Well, the equation for kinetic energy is 1/2 times m times v squared. So as long as the mass and velocity, it depends just on the mass and the velocity. Now the mass of this object isn't changing. But what about the velocity? Well, if you read this problem carefully, it says it's moving at a constant speed. So the velocity is not changing. Based on that, we can say that the kinetic energy is not changing. So the kinetic energy is constant. Based on that, what the problem gave us, it's moving at a constant speed. Which brings us to 85. State what happens to the internal energy of the crate as it slides along the incline. And the first thing to look at here is, what is internal energy? Well, internal energy is wasted energy, or energy lost due to friction. If you have internal energy, you put in a bunch of energy, and the energy that you get out of it is somewhat less, because some of it was lost. Looking at this, how much energy did we put into the system? How much energy did we give to this block? Well, that's the work that we did. We did 182.4 joules of work. That's what we gave to this block. But how much energy did it actually gain? Well, that's what we solved for in 8283. 120 joules. Notice there's a discrepancy here. We put in 182 joules. We only got 120 joules. So there must be some internal energy that is developed as we push the block along the incline. Since there is a gain in internal energy, for 85, we can say that the internal energy is increasing. Because as you push the block along the incline, you are losing energy, which means that that internal energy, that heat energy, is going